Hey, good morning, people. Thank you so much for joining us for this February presentation in the speaker series, Toxicology and Societies, the Impacts of Chemicals in Our Lives. I'm Tracy Collier, a toxicologist. I spent most of my career at NOAA's Northwest Fisheries Science Center. My co-host, hi Ruth, is Ruth Sofield, environmental toxicology and chemistry professor here at Western Washington University. Good to see you again. Happy February. We would like to begin by acknowledging that we at Western Washington University are on the ancestral homelands of the Coast Salish peoples who have lived in the Salish Sea Basin throughout the San Juan Islands and the North Cascades from time immemorial. Please join us in expressing our deep appreciation and respect for our Indigenous neighbors, the Lemhi Nation and the Nooksack tribe, for their enduring care and protection of our shared lands and waterways. A few logistics will save questions for the end of the presentation, but you can use the Q&A feature throughout on your screen at any time. You will be muted, so we'll use the Q&A feature to interact. You should have different viewing options in Zoom. We suggest you use speaker view so you can see the speaker and presentation at the same time. The focus of our speaker series is to provide understandable examples of how events with a toxicological component have consequences to people and societies. Today, we're really happy to welcome Diana Rollman as our speaker. Diana is an associate research professor at Oregon State University. Hi, Diana. Welcome. In the College of Public Health and Human Sciences, and she received her PhD in toxicology from OSU. Her work revolves around engaging communities, providing them information concerning environmental health issues, and better understanding how that information affects their perception and responses to environmental hazards. And just before the seminar, when we were setting up the logistics for this, I found out that she teaches the course in science, ethics, and Star Trek. It's something I'm going to have to look into. Anyway, but today, Diana is going to be speaking to us about a community-based research study involving people living in the vicinity of an industrial wood preservative facility near Eugene, Oregon, and her work in characterizing and communicating their exposures. Welcome, Dr. Rollman, and thank you so much for joining us today. I'll see you again at the end of your talk.
Thank you so much for having me. I'll go ahead and share my screen. Before you hop off, Tracy, if you can just let me know if I've properly shared this.
It looks good. Yep.
Perfect. All right. Well, thank you all so much for having me. I was telling the host right before I joined, this is a seminar series I have actually assigned my students for several years because I think it's such a great introduction to how public health and toxicology really interface with the issues that so many of us are looking at, studying, or experiencing in our lives. So really an honor to be here. So before I start, I want to acknowledge really the person that made this study possible, Lisa Arkin. So I have her photo up here as well. So she is the executive director of Beyond Toxics. And so a lot of the work that I'm presenting today came about from really over a decade of the work that Beyond Toxics has been doing. So I know she's going to try and join today. I don't know if she'll be able to make it, but I just wanted to acknowledge that this really was a community engaged study. Again, building off of the work that Beyond Toxics and specifically Lisa and Ardrey Arbery-Werybolt have been doing for a very long time. So I'm going to be talking about an air quality exposure study that was done in West Eugene. So just to share a little bit of background, again, I talked about Beyond Toxics. They are an environmental justice organization with over a decade working in West Eugene specifically. They've done quite a bit more work throughout Oregon. This particular project came about because Beyond Toxics was a member of a community core team with the Oregon DEQ, LRAPA, and OHA, specifically around concerns in West Eugene, Oregon, which is a mix of residential and industrial areas. And I should note that a lot of these residential areas are within a quarter mile, a lot of these industrial areas are within a quarter mile of residential areas. So we do have this interesting mix of people living very close to industry. We also know in this particular area that soil, air, and groundwater contamination have been previously reported. I'm not going to talk about all of that. I'm going to specifically talk about some of the air quality concerns. And these are concerns specific to polycyclic aromatic hydrocarbons. I call them PAHs for short. If you're not familiar with polycyclic aromatic hydrocarbons, the most simple definition is that they are produced when you're burning organic material. And I'm going to pause and apologize if you hear weird noises or see my background flicker. It's because I have a senior dog who is pacing because she wants lunch. She doesn't get lunch. She only gets dinner, but breakfast and dinner. So I apologize if that disrupts everything. So we know that several of the facilities in this area are emitting polycyclic aromatic hydrocarbons. And in fact, there's been some investigations done previously to look at these. When we're looking at wood processing facilities specifically, there's often the use of creosote, and creosote is known to contain multiple PAHs, specifically naphthalene. And if people are familiar with naphthalene, it has that very kind of characteristic chemically smell. For those of us that might remember, the original mothballs were impregnated with naphthalene. So if you've smelled that, you probably know exactly what I'm talking about. For a little bit more of the background in terms of what these communities have been doing for decades, I'm sharing this static image. This is actually an interactive map, and I'm happy to share the links to this later. We developed a story map, but this is showing odor complaints that have been received by El Rapa in this area. Now, most of these complaints were specific when the complainants called in. They believed it was due to the wood processing facility in the area. But you can see how over time, the complaints, right, we saw a lot of complaints in the early 2000s, but even continuing into 2020. And we're able to actually show approximately where these complaints are coming from. So really looking at the north, northeast and northwest to this specific area. So a lot of this has informed the work that's been done. In 2007, there was some air sampling that was done around this specific facility within some of the residential areas. And they really tried to identify conditions where contamination would be the highest. So on hot days, when facilities were operating at maximum levels, and then they put out samplers to look for polycyclic aromatic hydrocarbons. And so here you're seeing that naphthalene that I mentioned, which again has that very characteristic scent. And so they did find PAHs, which is not a surprise. PAHs are pretty ubiquitous. And specifically when they did look at naphthalene, we do see that it slightly exceeded the health guidelines at the maximum concentration detected. And again, we are looking at the sort of like the best conditions for contamination, but it was a slight exceedance. And so at the time, I think a lot of the community members were sort of interested in saying, all right, what's happened since 2007? I'll also note that Beyond Toxics has characterized ongoing health complaints from individuals in the area, specifically headaches, nausea, dizziness, difficulty breathing, eye irritation, and these can be reported after exposure to many chemicals. We also do see them reported after exposure to naphthalene. So this is sort of the full background in terms of what had been happening, long before I became involved. So in 2020 is when Beyond Toxics reached out to me, and we'd worked together on other projects, and they said, do you think there's anything that we can do to sort of gather more information that would supplement what we're already seeing in terms of community complaints and odor complaints and the sampling that's been done previously? So a little bit about me. I am a community engaged researcher. So most of my work really falls down on the bottom side of this spectrum. This is an image that we actually developed for one of our larger grants, where we sort of compared and contrasted the differences between investigator-initiated research and stakeholder-initiated research. This is not to say one is better than the other. They're very similar. The difference is how you are sort of starting and where you might end up. So in this case, we already knew that the exposure or disease hazard was specifically concern around exposure to polycyclic aromatic hydrocarbons from industrial sources. The concern was, what were these levels? Were they higher than they should be relative to health suggestions? And so this is where I come in. I started working with Beyond Toxics, like I said, in 2020, and we decided we could submit a small pilot project around $25,000. And we had this question of, all right, what can we do? We already know, based on prior literature from creosote production facilities, that we see a pretty sharp drop off in exposure to PAHs after about a mile. So we were able to limit our study area to a 1 mile radius, which is very helpful. When your budget is only $25,000, you're going to be limited in how much sampling you can be doing. Beyond Toxics was also really familiar with what sampling had been done previously, where it had been done, and they were intimately familiar with the community complaints and specifically where had odors been most commonly reported. So with that, we developed the study, and I really want to highlight how we did the collaborative research of this. For those of you that have done studies, particularly studies with humans, you know, there is a very long ethics approval, very important. Beyond Toxics went through all of the required ethics training. So for those of you that have done city training, you know what I'm talking about. They were full members in the entire study, co-developed all of our recruitment materials as well as our survey tools. And then we're also trained in how to deploy our samplers. So I'll talk a little bit about what we actually ended up doing in this study. So, you know, we have a focus on polycyclic aromatic hydrocarbons. I'm specifically interested in the semi-volatile and volatile polycyclic aromatic hydrocarbons. So with a limited budget, but a very defined target area, we decided to try and characterize the type and number of PAHs in the air in West Eugene. And we wanted to do this two ways. We wanted to look at ambient air, but we also wanted to look at personal exposure. So we selected passive sampling devices. I've worked with these quite a bit. These particular passive sampling devices come from the laboratory of Dr. Kim Anderson, who's been using passive sampling for quite some time. So what I'm showing here is sort of a blown up example of our ambient passive air sampler. So this is actually just a metal cage designed to protect the sampling strips, which you can sort of see here in the salmon color. Largely, this is going to keep rain and particulate off of the samples. I can also share that if you are using these out in like a sheep field or a cow field, it turns out that animals love rubbing up against these. So it can also be a great deterrent to getting a lot of sheep hair or cow fur on your sampler. So we set those stationary samplers around the industrial area, so that 1 mile radius that we had defined. And we went across all 4 cardinal directions for 7 days. And that sampling design was really influenced by the odor complaints that had been received for several decades. Within that same area, we recruited individuals to wear personal passive sampling wristbands for that same 7 days. So we had those paired environmental and then personal samplers. And then the idea was to analyze all of our samplers for 63 different PAHs. Importantly, the 63 PAH list includes the PAHs that had been previously analyzed in that 2007 report. And we were most interested in naphthalene and naphthalene, like alkylated naphthalene, so methyl naphthalene, et cetera. And all of those are included in this list. So to give you an idea of the importance of how we tried to recruit and gather this information, as I mentioned, Beyond Toxics was instrumental in developing all of our materials. This was, we started this study in March of 2020. We were funded in April, and then we began recruiting and the actual study in September of 2020. So as a result, we had to make sure that we were being very responsive to COVID-19 protocols. We ended up doing the entire study as remotely as possible, which means that for individuals that were wearing a silicone wristband, we actually dropped it off a packet on their front porch, and we left training materials inside so that they could read about the passive sampling wristband. They could understand how it works, what it does, what type of data we're going to get from that. After they wore it for the 7 days, they're able to put it back in a bag, put it on their front porch, and we were able to pick that up. So we spent a lot of time trying to make sure that our materials had a nice graphic interface, provided the information at an accessible reading level and in a way that was very clear and not scientific-y and jargony, which is something I think a lot of scientists, myself included, are typically guilty of. I'm also showing the type of infographic that we have developed for other projects and used in this one, just to provide more information about the silicone wristband and how something so seemingly so simple can collect so much information about the chemicals that you may be exposed to. We did also ask individuals to fill out a daily activity log. This can be really helpful for us to understand other sources of PAHs. So again, if you're not familiar with PAHs, they can be found from very natural sources. So unfortunately, all the wildfires that we've been experiencing are a great source of PAHs. But then they can also occur from industrial and human activities. So industrial air pollution, vehicle exhaust, our natural gas fireplaces, natural gas stoves, etc. Again, anytime you're really seeing that combustion activity produces these. So that activity log has been really helpful for example, if someone says, hey, I have a wood burning stove in my house and I used it on a Saturday, that helps us understand some of the different sources a person might be exposed to. So to show you our original design, this was sort of the specific industrial area that we're looking in. And again, so we went out to a full 1 mile radius. So we wanted to do concentric circles, and we ended up doing an inner circle, which was within a 1/4 mile. And we do have residential areas within that 1/4 mile. And then we went out to a 1/2 mile and a full mile. So the little human icon means that we were using personal samples. The little blue dot was an environmental sample. You'll notice that we did not collect any personal samples to the south of this area. And that's because the industrial area actually continues quite a bit into the south and expands. So we really didn't have residential areas there. We still wanted to collect the environmental samples there for comparison, but that is why we did not have personal samples there. And I'm happy to talk about that in more detail. So this was our proposed design. Everything always looks beautiful when you all lay it out. But what's really incredible, and full credit to Beyond Toxics, this was the plan that we ended up with. So Beyond Toxics did all of the recruitment, reaching out through their established networks, even going door to door as needed. And you'll notice again, we've got the blue representing the stationary monitors and the wristbands representing the purple. These are approximate locations, of course. And what was really incredible is we were able to co-locate a lot of these samplers. So wherever we had an environmental sampler, we had 1 or more wristbands located there as well. So you can see that we were able to represent these different cardinal directions, and we were able to get some environmental samplers in the south. I always like to show photos of what fieldwork actually looks like. So as I mentioned, we did have 2 Beyond Toxic staff that were incredibly awesome and just willing to come out and say, train us how to do this. We want to learn how to do all of this. So you're actually seeing Arjory Arbery-Berrybolt, who works for Beyond Toxics. This was her first training on how to set up one of the environmental samplers. So they're a little harder to see in this picture because the sampling material is actually clear. But so she is stringing one of our samplers here. Eric, another Beyond Toxics employee, is shown hanging up one of these monitors. This is Dr. Lane Tidwell, who helped me with the study. You can see occasionally we have to get a little creative and use existing structures with permission to hang the different monitors. We do use trip blanks when we're doing this, so that will be additional sampling material that travels from the lab to the location with us and then back to the lab without ever being opened. So that lets us know if we have any background contamination. We ended up deploying it at 17 different stationary locations. We did deploy in triplicate at 1 location. So with these environmental samplers, 1 location we hung 3 so that we can look at variability between the samplers. And we made sure to deploy all the samplers about at least 1 meter off of the ground. And then we also disseminated 15 silicone wristbands. This bottom image that I am showing is actually in the industrial area, the broader industrial area. And you can see that there's a lot going on. We have freight yards, we have train tracks, a very mixed use industrial area. So we were a little bit concerned about all the different types of exposures that we might be seeing, but we felt it was important to try and characterize those different exposures as best as possible. So with that sort of quick overview of what we were looking for and how we set up this study, I wanted to dive into some of the results. So I'm going to start with a broad overview, just really more descriptive statistics, and then show some of the preliminary data that we're seeing come out of this study. So one of the first questions we were interested in was just out of the 63 PAHs we looked for, how many chemicals did we actually detect? Now, when I say detect, I am talking about chemicals that were detected above the limit of detection. Happy to talk about what that means in more detail in the questions if people are interested in that. But because we knew a lot of this data was going back out to community members, we wanted to have a pretty clear cutoff. And so for this, we said if it was detected above the limit of detection, we're going to include it in this analysis. So as I said, we had 17 environmental samplers. We ended up having 13 wristbands returned to us. In the environmental samplers, we found 40 total PAHs, with about an average of 34 PAHs found per sampler. And then across all 17 samplers, we saw the same 23 PAHs in each sampler. When we then look at the 13 silicone wristbands, we saw only 22 total PAHs detected across all 13. That was about an average of 14 PAHs per wristband, which, having done several other studies with this, that's a pretty common average detection. And then we saw 8 PAHs in common across all 13 wristbands. So because we know that personal exposure is going to be very different than our ambient, right? As humans, we move through multiple different environments in our day. We wanted to see if there was any overlap between the PAHs detected in the environmental sampler or the personal passive sampler. And so we just did a very simple Venn diagram. And it ended up being very simple because all of 22 of the chemicals detected in the wristband were also found in the environmental samplers. So that was a little bit of a surprise to me. We typically see a few unique PAHs found in the wristband compared to the environmental sampler, but in this case, we saw just that complete overlap. And then we did see 18 PAHs that we only detected in our environmental samplers. So from there, we started to dive a bit more into the nuances of the data. And so what I'm showing here are the questions that we had been asked by community members and had really been influenced by all of the work that had come before this. And one of the questions really was, are chemical levels higher if you live closer to the industrial part of West Eugene? Now, I am going to caveat this, as you saw, this is a small study. We were limited in how many samplers we could put out, given a $25,000 budget. So we first approached this just by saying, all right, we found 40 PAHs in the environmental samplers. Let's just add them all up per sampler and take the average. And so that's what we're seeing with this first graph, this sum PAHs. We're using nanograms per meters cubed for the unit. So we are able to take the environmental samplers and back calculate to an air equivalency. So what we see here is if we run a Kruskal-Wallis, which is a one-way ANOVA, we are seeing that there is a statistically different result if we look at the levels of PAHs within that inner ring, so within a quarter mile of the industrial area, relative to this total pH levels seen between a half mile and a mile away. So we're actually seeing this very nice step down sort of model here. When we break that down and look specifically at naphthalene, which is the chemical that we were most interested in, we see the same relationship. And this, again, was a statistically significant relationship where the farther away from the area you get, the lower the levels of the naphthalene. And when we look at several other PAHs that are associated with creosote use specifically, so acinapthalene, 2-methylnaphthalene, 1-methylnaphthalene, and then fluorine, and even phenanthrene, we again see this relationship where levels are highest in the inner ring and decrease as distance increases. I think, yeah, we're going to wait on questions, but I'm happy to talk more about this. We're still digging into what precisely this information can tell us. One of the other questions we got, though, was, do the levels of chemicals change based on wind direction? So that's a slightly more complicated question than I can answer at this moment, but what we did do was separate out our samplers based on their cardinal direction. Now, you're going to notice a lack of error bars in this, so we are very limited, again, by the number of samplers that we have. If there's no error bars, that means it was a single solitary sampler, so we are going to take this, I usually say, sort of with like a half barrel of salt. What I wanted to point out, though, is how this type of work can really integrate well with the work that's being done by community organizations or communities. Because what we are tentatively seeing is that we saw higher levels of some PAHs in the Northeast and the North and the Northwest. And if you remember that image I showed of the odor complaints, that's actually where we were seeing a lot of the odor complaints. Now you'll notice we're also sort of seeing this step down model here with a lot of these. Obviously, we are missing some samplers where we weren't able to find locations. We do see higher levels of some PAHs in the South. Not really a surprise. We know that it's an industrial area. It was a bit of a surprise to see the difference between the South and, for example, the North. But we do know that the South, where our locations were upwind of the area that we were most interested in. So when we look at some PAHs, we can also do the same and look at naphthalene. It's not really a surprise that we see the same thing. If you're looking, sorry, I hate to do this in a presentation, but if we notice our units here, we're going up to about 4,000 nanograms per meters cubed. When we look at naphthalene, we're seeing that this is obviously a very large component of that sum PAHs. So it's not a surprise that we see this similar pattern here. But again, integrating with the community concerns around odor, we're seeing higher levels in the Northeast, both at the inner ring and sort of that middle ring. With naphthalene, there are some guidelines that we can compare our data to. So specifically in Oregon, we do have a health guideline for naphthalene. Now, the good news is the levels would need to exceed 3,000 nanograms per meters cubed. And so we are below that here. I did want to try and put this data in more of a comparison though. So we went through the literature and we looked for studies that had used similar sampling approaches, similar timeframes, and that were looking at the volatilized naphthalene. So naphthalene can exist as a particulate. We were specifically collecting the semi-volatile and volatiles of PAHs. So what you're seeing here is these black bars represent the inner ring, the middle ring, and the outer ring of our samplers specific for naphthalene. And again, we're seeing this very characteristic step down. I then took all of the samplers we had, all 17, and took the average naphthalene level, which is represented by this blue bar. So again, you'll see that we're well under the 3,000 nanograms per meters cubed, which is that health guideline. But then we were able to graph in data from other studies. So these bars here are representing Michigan and Detroit. And you'll see here, these samplers were in a dense population, heavily industrialized. Here is an urban and suburban area of Michigan. Here's just the suburbs. These samplers were near road in Detroit. And then here's what a commercial industrial area in Michigan looked like. And then for total comparison, we had done a study with Kim Anderson in Ohio, so a very rural area near unconventional natural gas drilling. And I'm showing the levels of naphthalene here. So we can sort of get an idea of how this inner ring of Eugene is looking more comparable to the densely populated industrialized area of Michigan, or sort of that urban and suburban area. It is not a surprise that we're seeing levels higher than rural Ohio, but we wanted to try and provide this contextual data to provide context. I didn't think that sentence through very well, but we found that this has been really helpful versus just saying, hey, the levels in the inner ring were at 350 nanograms per meters cubed. That doesn't really answer the question of like, what does that mean for us as a community? So we can try and provide this to help answer that question more. So that is the environmental samplers. We did a similar sort of analysis with the silicone wristbands. Now, I will say with the silicone wristbands, we are not currently able to back calculate to air equivalencies. So the units we're showing here are the nanograms per wristband. And so I looked at the some PAHs here. Again, we did the same thing with naphthalene, and we're seeing, again, that similar step down, and we are seeing a statistically significant results when we look at levels go down the farther you get away from this area. So we can provide some information for this question. We once again looked at how, if people are upwind of the facility, are there different exposures there? And again, we're seeing higher levels in the north, northeast, and the northwest, but again, very limited on sample size, and we don't have a lot of replication to support a lot of this. So I'm showing here the some PAHs that we looked at. So very similar as to the environmental samplers, just different units. When we break it down to the naphthalene, we actually do see a bit of a difference here where the levels in the north are going to increase, but that is going to be a single wristband. So here we have much more potential for the silicone wristbands to be representative of personal exposures. Now, I don't mean that is that this participant is engaging in behaviors that are going to increase their exposures, simply that for reasons potentially out of their control, they may have to go to areas with higher pH levels, or they may have an occupation that also exposes them to higher levels. So when we are looking at human variability, it does help to have a lot more samples here, but we do ultimately sort of see that we're seeing higher levels in the north, northeast, and northwest. But again, we're missing samples in the east and the west. So that is the preliminary data that we have dug into so far. What I wanted to actually end on is another component of doing community engaged research, and that is the return of data. So we're still in this process. We have actually returned aggregated data so far, and I'm going to show you how we've done that. But this is something that I feel very strongly about. I know of the communities I've worked with, this has been an integral part of participating in the research. And it really is getting back to this idea of communities have these concerns. They've done work around it. Our science is not to validate their concerns. It is merely to provide another perspective that can go along with their the data they've already collected. And so to do that, we need to be able to return the data in a way that makes it available as well as accessible. So we have been heavily influenced by the work done by Silent Spring. We ended up creating a 4-page aggregate report. Beyond Toxics, again, was instrumental in this. So I know there's a lot of text. I don't expect you to read all of this. This is publicly available. But what we try and do is start with a brief summary of, what did we do? Just sort of a reminder, because usually it's been several months, if not a year, by the time we've collected data, gotten it processed and analyzed it. And then we broke it down into what are the questions that were asked of us and what did we find? Can we address those questions, yes or no? We do try to provide more information about polycyclic aromatic hydrocarbons. And then we walk people through the timeline so they realize every step of the process and what we did. We showed a very generalized example of the study design. So again, we're seeing here this inner ring, the middle ring, the outer ring. We've got the cardinal directions noted on it and a description of the 2 different types of samplers that we used. We also, when possible, try and show photos. So again, people can be like, oh, that's right. That's why there was that weird metal box up in the yard for a while. We provided a link to a story map that was specific to this area that we were specifically working in. And then the last 2 pages, we went through the data. So you're going to recognize these graphs. This is what I just walked through. We specifically developed these graphs to try and make sure that they were as accessible as possible. We walked through the different ways that we analyzed it, right? We went by distance, we went by direction. With the environmental samplers, we were able to compare to other studies. And in each case, we tried to do as simple and short as possible a description of what we saw and what we think that might mean. We did the same for the wristbands, where we did by distance and by direction. We weren't able to do as much comparison, again, because with the silicone wristbands, we're not able to back calculate to air equivalencies. So this was one type of report we've done. We will be doing individualized reports as well. We're hoping to get those out within the next month. But essentially, that is where every individual in the study will be able to see the specific result from either their environmental sampler or their wristband sampler or both within the context of the rest of the study. And again, we're influenced by how Silent Spring has done that for different ways to visualize that data. As a result of this study, we were able to be involved in several other ongoing efforts around this. So I mentioned this area is heavily industrialized. One of the facilities there is J.H. Baxter & Co. And there was a lot of work being done around this to address community concerns, well-documented issues of contamination. And so we were invited to take part and help develop a story map. So there is a QR code here. I don't know if that works off of your screen. I can also drop the link in. But what we were able to do is develop this interactive graphic, and I apologize, it's pixelated, but we wanted to have a simple graphic that can really help people understand what is a risk assessment. What does that mean from a regulatory standpoint, and what might that mean for you as a community member? So in this graphic, as people click on the different little plus symbols, a different text box will come up and it will provide information about like what is risk. And we linked to some really fantastic videos from a YouTube series called Risk Bites. If you haven't checked it out before, I highly recommend it. We were also able to sort of say, like, how is risk calculated based on contamination from water versus air versus groundwater? And how do all of these different regulatory departments and agencies work together to try and characterize and identify risk? So that was one thing that we were able to help with.
What is risk?
Another process we were able to help with, and this is much more serious than a story map, because of so many community concerns, as well as community documentation of cancer cases in the area, the Oregon Health Authority offered to do a cancer analysis. And so for those of you that might be familiar with a cancer analysis, it is actually a very rapid process. It uses an existing database for Oregon. that's looking at cancer incidence. And you can actually break it down to a census tract and say how many cancer cases of a specific cancer type have been identified over a certain time period. And is that greater than, less than, or the same as what we would anticipate based on the population of Oregon as a whole? And so we ended up looking at 22 different cancer types. Those cancers were selected based on known associations with exposure to polycyclic aromatic hydrocarbons. And unfortunately, the cancer analysis did find that rates of lung cancer and Hodgkin's lymphoma were slightly higher. Now, for the other 20, rates were the same or lower than expected. So we also did a lot of work talking about what does this mean, right? What can a cancer analysis tell us? What can it not tell us? And what are other health concerns that it really doesn't help inform us about? So through my research center, we worked with Oregon Health Authority. Obviously, they did the entire analysis, but we worked with them to put that analysis into this one-page infographic, which enabled us to get that information back out to the community much more quickly than if they had gone through the formal, 22-page write-up. So this is something that we were really happy that we were able to contribute to as part of this overall air quality study. So with that, I'm actually ending a little bit early. But I did want, again, to give incredible thanks to everyone at Beyond Toxics. I'm listing the whole team here. So Michelle and Lali and Anna were instrumental in helping develop the IRB. I didn't mention this, but our materials were actually available in English and Spanish. So working with translators to make sure that those materials were more accessible. Marjorie and Eric are the ones that you saw out in the field with us, deploying those samplers, helping us then go back 7 days later and pick them up. And then Lisa is the impetus for this work. This would not have been done without Lisa reaching out and saying, hey, I'd like to work with you. Can we get this done? Also, incredible thanks to the Chemistry Exposure Corps that we have here at Oregon State, directed by Kim Anderson. Pete Hoffman is the assistant director, and then Lane Tidwell, who gave up 2 days to come out and help me deploy samplers, pick them up, and then help with all of the analysis, as well as incredible thanks to West Eugene participants who have remained very engaged in this study. We've continued to do community meetings with this group. And then all of this research was funded by our Pacific Northwest Center for Translational Environmental Health Research. It's a long title, apologies, at Oregon State University, and we're supported by funding from NIEHS. So with that, I am happy to take any questions, and I'll stop sharing so that we can see the other co-hosts.
Thank you. Thanks so much, Diana. This was really great. It's a great example of community interaction, working with the people in the affected communities and trying to really get the information back to them about their lives and their situations. I think the overarching question that several people have had, myself included, when you do this interaction with the community and you give them back the information, and I understand it's early days on this project, but in general, for this community in West Eugene and other places where you may have experience, how do people respond? What's the general reaction? Is it skepticism? Is it I wouldn't say happiness for some of the results, but just in general, how do people respond to the fact that they're getting this information back and it's telling them something about their personal environment?
Yeah, I'm always happy to talk more about the ethics involved in this. As you mentioned, I teach an ethics class. A lot of this work has been done by researchers that came before me, but this is a question we get asked pretty frequently because the concern is you're giving people data that could make them concerned about their exposures and what can they do about that. What's been interesting is that others and myself have found that oddly people actually are happy, right? You said, like, are they happy? But yes, because there's finally transparency, especially in the work that I'm doing. Usually, again, I'm brought in very early. We're co-developing the research design, and we know that we want to be returning data from the beginning when we're planning this. And so we put a lot of work into talking to our participants about, here's what we want to do, here's the type of data we can collect, and here's the type of information we could then give you. And being very clear that we're not going to be able to answer everything, not because we don't want to, just because we might not be able to collect that type of data. So I can share a couple different anecdotes, not from this study specifically, but I did have a participant in another study. They had very high levels of a PAH called benzoapyrene. and that is a known carcinogen. There's no safe level of benzoate pyrene. And honestly, I'm a toxicologist, I'll never say safe because everything, depending on the dose, can be a poison, but they did have high levels of benzoate pyrene compared to the other people in the study. And they looked at their individual report and they looked at the table and said, okay, benzoate pyrene is a carcinogen. It's found in cigarette smoke, vehicle exhaust, burning of coal, etc. And the participant came up to me later and said, my mother-in-law smokes in the apartment around my kid, and I've been asking her not to. Do you think my high levels of benzoate pyrene could be due to cigarette smoke? And before I can say anything, she's like, this is perfect. I finally have the best example to show to my mother-in-law that, like, yes, her smoking the cigarette is detrimental to our air quality. And we know now that we're being exposed to a carcinogen. So it was honestly odd to me. Like, I thought this participant was going to be very upset at seeing these high levels of benzoate pyrene. And instead, they ended up feeling incredibly empowered because they're like, I know where it's coming from. I know how to fix it. And now I have this additional proof that really corresponds well with what I was pretty sure I already knew. We've had other participants say, like, yeah, they're not happy, but they knew there was a problem beforehand. And this just sort of provided additional evidence for that. What I didn't show in this report is we also try to include resources for individuals that are concerned, how they can reduce their exposure. And we try to do that across a spectrum of low cost to high cost, low effort to high effort, to make sure that everyone feels like they can do something.
Great. Yeah, that's always good to hear that people, in general, people do better when they have more information. Creosote is a pretty nasty, complex mixture of a lot of stuff. We've dealt with creosote issues up here in the Puget Sound for aquatic toxicology. Do people ask you questions about, well, yeah, you're looking at 63 PAHs and you're finding 40 of them. What about all the other things, all the nitrogen containing compounds, the carbazoles? Number one, do they ask about that? And two, is there a skepticism that those things aren't being measured? And in many cases, we don't even know some of what those compounds are. How do people deal with that, or how do you deal with that if you get questions like that?
Yeah, in this particular study, no, we didn't have that. And I think that's just because this community is so incredibly aware of the fact that PAHs were one of the bigger problems, and because they could literally smell and say, like, we know that's naphthalene. So in this community, the focus on PAHs, as long as they knew, like, yep, you're collecting PAHs that are found in creosote, we were pretty solid there. In other studies, yes, absolutely. And I think that again goes back to setting those expectations at the very start of the study, holding those community forums, working with community organizations and liaisons, and saying, yeah, there's thousands of chemicals, right? We know there's like 80,000 chemicals in commerce, and we don't have good toxicity information for all of them. In fact, we have good toxicity information for less than 10%. But it's a conversation of saying, here's what we as scientists have skills at looking for. We're really good at looking at PAHs, and we actually have one of the bigger PAH analytic screens. We're not saying everything else is not a problem. We're just saying that we don't have the expertise to appropriately look for that. And then there's also the budget constraints. And I have sat down with community members and said, here's what it costs. And it's not making profit, right? We're academics, we're not in it for profit. But just to try and say, like, really validating what we're hearing from people, acknowledging it as a concern, but then also explaining we're not dismissing that concern. It's just not something that we are equipped to handle.
We had some questions from people asking, and I think I know the answer, but I'll let you answer it. When you put up the samplers, the air samplers, not on the wristbands, but the samplers, are those all publicly accessible, or are some of those within the facilities, like within the industrial facilities, or within facilities where you might expect high levels? But I'll let you answer that.
For this study, the environmental samplers were placed at residences and businesses. So publicly available in some senses, but for residences, we typically try and put it in a backyard where it's fenced. For areas where it was completely publicly available, I think you saw that picture of Dr. Lane Tidwell actually standing on top of a car, putting a sampler up. So we do try to put them in areas where they're not going to be accidentally bumped into, messed with, etc. And then for businesses, we worked really closely with them to make sure that we were putting a sampler out of the way where it wasn't going to interfere with their regular business practices.
I'll just point out that standing on top of a car is not considered to be a good safety practice. So I hope your university safety people don't see that. The other questions revolve around, do you, and again, this was not what your study was designed to do, but people are curious, if you were to put these wrist samplers on some employees in these facilities, number one, have you done it? I don't think you did in this study, but if you did, what kind of levels would you expect? Would they be higher levels of exposure, presumably? And again, this is up to you.
Yeah, no, that's a really interesting question. I mean, so I'm not an occupational health toxicologist. I can really only answer that based off of what I've read from other studies, not specific to this, but I do know from other occupational studies, what they've seen is that exposure is dependent on location within facilities, as well as job type. So if you're a person that is specifically working close to the ovens where the creosote is being applied and then impregnated, I would probably expect to see higher levels there because we're seeing higher temperatures and you're working directly with the creosote versus someone that might be on the other side of a facility working outside.
And when you gave the levels of concern, the exceedances, you had some exceedances years ago. Are those levels of concern, is those for occupational exposures or are those for?
Those were for residential.
There's residential exposures. Okay, so it's not.
Yeah, and so that work was done by the Oregon Health Authority.
You talked about gas stoves and wood burning fireplaces. What do we know about what would people levels of exposure be if they had a wood burning stove in use in their house? If we know that, if you're using a gas stove range top, does that increase your levels of exposure? How much do we know about that?
I don't have enough data from my research to answer that. There's a faculty member at Oregon State College of Public Health, Molly Kyle. She released a study several years ago. They were using data from NHANES. And so they were able to see that individuals with young children in the home with a gas stove, they saw increased asthma incidence in homes that did not use ventilation when using their gas stove. And I'm sure you know there's been some talk in the news lately about potentials for regulating gas stoves out of concern of indoor air quality. For wood stoves, I don't have a good answer in terms of like specific levels, but yes, we do tend to see higher indoor air quality with people that are using a wood stove.
Okay. What about alternatives to creosote? Again, in my career, I've worked a lot on wood preservatives, different kinds, and creosote, and mostly for in-water use. But in a lot of creosote these days is used for, obviously, for like telephone poles and things like that.
Railroad tracks.
Railroad tracks. So talk a little bit about creosote and sort of what other alternatives are out there in terms of ways to do these things and preserve these structures better and safer.
That is a really great question, and unfortunately not one I can answer. Okay.
I just tell everybody to use concrete. Use concrete whenever you can, although it's got its own environmental issues for sure. So I think you talked about that there have been some closings of facilities in the area, some changes in the industrial patterns. Do we know anything about how that might have led to any changes in exposures?
Really good question. That's actually what I've gotten from several of the communities, right, where they were saying like, all right, there's been a closure. What would happen if we did the study again? So I can't answer that definitively, right? I mean, while we did see the higher levels closer to that industrial area, we can't pinpoint a precise source, right? Naphthalene is ubiquitous, and there's really no way to do chemical fingerprinting to say, that naphthalene came from this facility versus the fire down the road. What I can tell you is from Beyond Toxics, they said they've actually heard from a lot of really happy residential areas that they're not smelling those odors as frequently and that it smells a lot nicer. So I do like to be able to use community anecdotal evidence wherever possible. And ultimately that's what people were wanting. They wanted the air to smell better and they didn't want to have air that felt like they couldn't leave their home.
The human sense of being able to detect smells and odors is pretty phenomenally sensitive. It is. Yes. And it doesn't match up with our ability to measure the chemicals in many cases. So that's given that there were no unique PAHs in the passive wrist samplers. compared to the samplers near to the facilities. Does that say to you that the facilities are the dominant source of PAHs that were being found in people's wristbands?
I think I'd be better able to answer that if we had a larger sample size. Right now, what it says to me is that there's a sort of a common set of PAHs that people are exposed to. One of the next analyses we want to do is try and pull data from other wristband studies done in Oregon and other areas and sort of see, like, of those 22 that we found in the wristband, how many of them are just frequently detected in wristbands independent of location. And I can already tell you that several of those I know are just going to be frequently detected.
We have another couple questions. Did you look at the demographics or try to better characterize sensitive populations in the areas that had the higher levels of PAHs?
We did a pretty extensive questionnaire when people signed up for both the environmental sampler and the wristband sampler. And as you saw, we actually had a lot of co-location. So people with environmental samplers also tend to wear wristbands. So we are going through all of that survey data. But yes, we did collect sociodemographic variables as well as some health indications, because that was something Beyond Toxics was also interested in characterizing, is the relationship between the environment, chemicals in the environment, and potential relationships to health as well. So we have all of that information, just need to go through and analyze it.
I'm going through, I've been trying to sort of bin the questions, make sure I haven't missed any.
Yeah, sorry, I talked a lot faster than usual. I'm normally over time.
One question, and again, a little bit outside your subject area, but do we know if the presence of trees, of large trees, would that mitigate the PAHs in the air? Do we think? Do we know?
It's a really good question. I have like enough knowledge to be dangerous on it. So I am part of our Superfund Research Center here at Oregon State as well. And we do have an investigator that's looking at remediation efforts. So he's more interested in bacteria, right? Can there be bacteria that can essentially glom onto PAHs and break them down? But through that, we have worked with other companies that are interested in bioremediation. So specifically, are there planting of certain trees or plants that you can put out to try and reduce those levels? What our research has shown is that in some cases, yes, you can reduce the parent PAH. The flip side, though, is what about the metabolites that it creates? So Lou Semprini is one of our faculty members. He has looked at bacterial remediation of phenanthrene. So I showed some of the phenanthrene levels with the environmental samplers. Phenanthrene is not super toxic. I mean, it is a respiratory toxicant, but tends to be at higher levels that we're seeing that. So we don't characterize it as toxic, but when it is broken down by bacteria, we actually see much more toxic metabolites. So the area of remediation is one that I am fascinated in, but I think it's also going to require a lot more careful consideration of not just focusing on what's the beginning PAH, but what are all the secondary, tertiary, quaternary, and so on breakdown products, and how do we characterize the toxicity of those?
Great, thanks. We have one sort of a technical question. What's the process by which you guys get the PAHs off of the wristbands?
I actually have videos that I am happy to share for that. So there's a couple different processes. I am not the analytical chemist in this. This is going to be Kim Anderson's group, but if you go to, I think it's like fses.oregonstate.edu. We have several videos, and one of them is showing a solvent extraction that's been used for the silicone wristband. So my very simple non-chemistry explanation is take the wristband, drop it in a jug of solvent, and then through a series of continued extractions, you're going to blow that solvent down to something like 100 microliters. And from there, you can take that extract and you can throw it on the GCMS.
Very well done, encapsulated.
Thank you.
Analytical chemistry, thank you, yes. Yeah, those questions come up for people all the time. And again, we're gonna post this online, and we'll get other questions that we haven't covered here that come in later. We'll send to you and give you a chance to answer those, and then you can add links to what you answer, and then that's available for people to look at later. So
yeah, and I'll put this in for the hosts and panelists if you're able to share in the Q&A. But FSES, that's the Food Safety and Environmental Stewardship Lab, directed by Kim Anderson, and there's a tab under there for videos. And so if you go to those videos, you can actually see how the wristbands are extracted and the type of information we can gather from them.
And then a question just came in, the people that were in the zones closest to the industrial facilities, is there, you'll get the demographics, but do you know already, it's in general, or are they of lower socioeconomic status?
That's probably a better question for folks at Beyond Toxics, but that is my understanding. Yes. And that is why Beyond Toxics has been so strongly involved in that area for so long.
Right. I mean, and we see that pattern so often, obviously. It's a big,
and it's a bigger question. I mean, for those of you familiar with environmental justice communities, this West Eugene area is considered an environmental justice community. And it is larger questions about, having residences and small businesses located within a quarter mile or even closer to industrial areas, and how the zoning works for all of that. And that's not something as an air quality toxicologist that I'm qualified to speak on, but it is something that we're aware of when we're doing that research and trying to characterize how close individuals might be to these, not in a name or a blame, but just an acknowledgement of how our built environment can be contributing to some of these exposures.
I think we'll probably cut it off here. I want to just say to the Beyond Toxics people, I see that some of you are online. Thanks so much for what you've done to contribute to this study. It's always great when the scientific community gets to partner with people that are coming at it out of concern about things, the types of issues that you folks are concerned with. It should always make us feel better about the work we do and why we do it. So thank you for your cooperation as well. But again, Diane, thanks so much for your time, Diana. It's been really nice. Great study, great work, and in a good cause.
Thank you. Thank you again for the invitation.
We'll be sending you some more questions in a little bit.
Happy to answer them.
Thanks so much, people.